a lot of you at time, so hopefully, we can keep this sweet and short, and we can get to Q&A right after. So let's wait for one more minute, and then we're going to start. And of course, during the webinar, if you have any questions or things that you would like to discuss or comments that you want to share, please feel free to share them in chat. Hello, everyone. I'm Faisal Nawab, and I'm currently an assistant professor at the University of California in Irvine. I'm really happy to be doing this webinar today. I know that all of you are part of our community of researchers and students who are interested in doing research and exploring this world of research projects and publishing your research. And today's webinar is about a topic that is very important, especially for someone who is starting to do research, but also for young researchers, even if you have some experience. Today, I want to share my thoughts about the process of doing research. I've been doing research projects for more than a decade, and I've thought a lot about the process, especially as a mentor, graduate students, undergrad students, and even high school students, and how we can start doing a research project, and what is really a process for us to do that. And today is going to be about my thoughts on how to start your journey of writing a research paper. Before we start with the actual material, again, just to emphasize that if you have any questions or comments, please share it in chat. And I'm going to take a break, every once in a while, to check the questions and answer them. But what I'll be covering today is going to be about, first, what is a research paper, in a way defining the scope of this talk and what we mean by producing a research paper, and also why you should care. Of course, people write research papers for a reason, and we want to discuss some of those reasons very briefly, as I imagine that most of you here today see the value of writing a research paper. After that, we're going to start going through the process of writing a research paper. And what I'm going to present is really a step-by-step approach, from the absolute beginning. How can you take a series of tasks and decisions to get to an outcome of a research paper by the end? So we're going to do that, but at the same time, please make sure that you have maybe a piece of paper and a pen, or maybe open your notepad, or text editor, because I'm also going to ask you questions, and I want you to answer those questions for yourself and try to see how this process can be applied for your interests and for your background. But we're going to get to that point in a little bit. All right, okay, so now the first question, which is what is a research paper and why we should care about it, is that a research paper could be, really, it's a general concept, right? It could be any type of written report that describes a research project. Right? So if you've worked on a project where you did some innovation, either in the technical aspect or the modeling aspect, or any really other aspect, depending on your problem, and you write a research paper so that you can have it outside, in the world, and for people to read it. And of course, the main goal of doing that is that you want to communicate your work. And there are, of course, reasons of why you want to do that. If you're a graduate student, or if you're a researcher working in a research department, this is part of your work. That when you work on research, you want to communicate it with others so that they can take your ideas and actually implement them and deploy them in real problems. The other important aspect, especially for students, is that you want an evidence of research experience. If you are a high school student or an undergrad student, and I see that there is a bunch of you who are in high school and undergrad from the poll, as a part of the admission process for universities now, one of the aspects that a lot of people look for, a lot of admission officers look for, is whether the student has some prior research experience. And showing that you have research experience can be by providing reports, can be through providing reference letters from researchers that you worked with, but mainly it could be through publishing research. And of course, if you publish this paper in a peer-reviewed journal or in a place where kind of like it has visibility, this would count as kind of like in a way more points, or in a way kind of like more influence in admission decisions and getting into a better place. So in a way, kind of like a lot of students kind of like are starting to get interested in research papers for that reason. But also, when we think about writing kind of like a research paper, and especially for those of you who are in undergrad or high school students, a research paper, kind of like when we think about it, is really as an indicator of the extracurricular activities that you've done. So even though that you have classes and you have a lot of things that is on your plate, investing some time on doing research and producing a research paper is going to have a huge impact on your profile, whether it's for graduate school, for undergrad, or for internships and potential jobs, to show that you've done something deeper with the knowledge that you have beyond what you take in school. And of course, depending on where you publish that paper, it is going to have different impacts. You can publish this paper, for example, in a peer-reviewed conference or journal, which would have, in a way, the stamp of approval from a research community. You can use that research project and paper to participate in research competitions. And you can also build a relationship using that work on research with a researcher or a professor who can provide recommendation letters that are also going to be helpful later in admissions as well as job opportunities. And one example that I want to show is of a student who kind of like in a way worked with us before, who started in 10th grade because I started reaching out to researchers to work on research. And by the end of that year, he kind of like started working with us, then started working in a research project. And by the time that he is in 12th grade, he published the research paper based on the work that he did with us. And he actually took that paper, published it in an IEEE affiliated conference, as well as won the second place in a K-12 research competition also affiliated with IEEE. And based on those achievements, that student was able to secure acceptance and admission to a top 5 CS department here in the USA. So in a way, those types of activities is really what can set you apart compared to others that are also applying to the same places. All right, so I'm gonna kind of like, let's say, take a quick pause here, see if anyone kind of like, if you have any questions that you have, please share them in chat. So one of the questions here is about whether the slides are going to be shared. Yes, so I'm planning to share the slides as well as the recording of the lecture, but that might take some time. So kind of like maybe in a few weeks, kind of like I'll have that worked out. All right, sounds good. Okay, so there is kind of like some questions about kind of like programs, certificates, as well as matching with PhD students, researchers, or faculty. So a lot of this, I can talk a little bit about it at the end. So kind of like in terms of, kind of like building a community and joining research projects. I know that a lot of you here are part of our mailing list where we advertise research programs and webinars such as this one. So we're going to kind of like have more information about this at the end. All right, wonderful. Okay, so now let's get started with the actual process of research. And the first step of taking, or in a way starting any research project, is to start thinking, well, what is the research problem that I want to solve, and what constitutes a research problem? And the first thing that we need to decide is we need to think about a scope for the research that we want to do. So not necessarily the specific problem that we want to solve, but rather what is the area of research that you want to do work on. And this might be like a very difficult question to ask, because there is a lot of things that we may work on. You might see some of your either friends or colleagues who have done research or maybe kind of heard about it in social media. And it seems that the options are limitless, and also how to define such a scope. So I have a very simple way of us to start, in a way, thinking and defining a scope for our research. And it is to ask two main questions. The first one is, what are your strengths? Right. So if you think in terms of your background, your kind of like the things that you've studied, the previous projects that you've done, either as part of school or as extracurricular activities, what are the strengths that you find in yourself? And the other question to ask is, well, what are your interests? Right. So in terms of things in general life, not necessarily in research or in school, what are your interests in general? And by answering these two questions, you can start combining them to start coming up with defining a research problem area. So let's take this exercise here, which is let's try to answer these questions. And I want you to do the same thing for your part. Of course, your answers are going to be different than the answers that I provide here, but these are examples to give you an idea and an intuition of what could be answers or the scope of such answers. So if someone asks you, well, what are your strengths in terms of science and research? One could answer that, well, my strengths are in computer programming. I've, let's say, done programming for, let's say, a couple of years, and maybe I took courses or classes or maybe online videos for computer programming. And maybe I also can say that, well, statistical analysis is something that maybe I studied in college, or in a way that's something that I picked up as an AP in high school. So kind of like in a way having a list of all these topics that you consider as your strengths. And of course, strength is of an area is relative. If you're starting research, of course, strength here does not mean that you need to be an absolute expert on those topics, but rather it's something that you've learned that you feel comfortable with. And if you feel that list is maybe kind of like, if you're writing this list and you're not too confident, maybe spend some time to build your strengths a little bit further so that you can start embarking on a research problem. And after that question for strengths, you can answer, well, what are my interests? And here you can really think kind of like in a more broader way. So whether it is something within technology or really kind of like a general life. So for example, one could say that machine learning for video analysis is an interest of mine. I'm interested in those types of applications. So I list it as one of my interests. Another one could be Internet of Things applications, and you could say that, well, I'm interested in, let's say, those types of applications with wearables, self-driving cars, and these nice things. And then you have these two aspects, strengths and interests, and then you would start to combine them to start coming up with general areas that you can start defining for the scope of your work. So before we get into that point, let's check on chat real quick. I'm going to see if like anyone has any questions. All right, so there is a question here which is about the publication of a paper and whether it entails kind of like monetary payments. It depends on the venue. Most of the time, it is not something that requires, in a way, providing payment. Sometimes it does, that there is a fee associated with it, but it really depends on where you're publishing your paper. But kind of like usually, kind of like it's either kind of like free of charge or would require kind of like some small fee for publication. All right, so let's see. I'm seeing the other questions. Okay, very good. So here is a very good question, which is kind of like, how do I know if my work or maybe my strengths are good? And that's actually something that we're going to come up with or come to mention later, which is in a way finding a community of mentors, of peers who can actually discuss with you, that can in a way help you grow and also see the work that you've done and whether it's good work. So we're going to get to that actually also later at the end of this seminar. Yeah, very good. So here is a good question, which is for the interest side, from where does it range? Could it go, for example, this is a bit trivial, from computer science all the way to art? So that's a very good question, and absolutely. define it in the way that you feel comfortable. And the reason why I say this is that this is not a linear approach. As I'm going to present these steps, once you finish step one and go to step two, and kind of like take in a way like what you defined in these initial steps, if you feel that what you defined is maybe too broad or too narrow, then you can go back to step one and in a way refine your selection of what is your interest and what is your strengths, and then in a way kind of like continue from there. So hopefully as we cover the next couple of steps and thinking in terms of that these steps are iterative is going to make more sense. Okay, very good. Okay, so that's good. So I think that there's kind of like some other questions also that maybe we leave to the end. It's because I think they're relevant to some other parts. So if I didn't answer your question and you feel it was not answered, let's say in the kind of like by the end, feel free to repost them when we have the open Q&A. Maybe we're going to take one more question, which is publishing a research in a quality journal or conference matters, as some have pretty high standards. That's a very, very good point. And that's something that I'm also going to mention a little bit later, but I'm going to comment on it a little bit right now, which is research venues differ. Some of them are very competitive, where, let's say, kind of like only a few tens of papers from all over the world are published, and usually there is very fierce competition from research groups to publish there. But also there are, in a way, less competitive journals that are still good, that are still peer-reviewed, that have the stamp of approval. Depending on your level and, in a way, what you want to achieve with your work, you would pick a venue that aligns with your interests. So, for example, as a high school researcher, it's not necessary that you must target, let's say, the absolute kind of like top journal that may require work that spans a few years, because in a way we don't have that time as high school students. But you can target venues that target high school student research, where it's more accepting of kind of like ideas that maybe are at a short term or projects that are done within a shorter duration. And we're going to get into that in a little bit as well. But now continuing in step one, once we've defined the strengths and interests, we can combine these two to have defined scopes of the work that we want to do. So for example, if these are the strengths and interests that I've done or that I've written, maybe I can combine them to say, well, maybe an area could be statistical modeling of machine learning and video analytics of smart cities. So as you can see, it's just like trying to bring those keywords that I defined and trying to put them together. Another example is maybe an efficient algorithm for fast video analysis for self-driving cars. And as you see, it's the same thing. I took the strengths and then tried to apply them to instances of my interest. So, for example, if you're interested in Internet of Things, maybe your interest could be specifically in self-driving cars. So that could be an example of what your interest is. And now, once you have defined these potential areas, then you would take each one of them and you would start trying to find existing work or prior work for that area. And this is step two, which is a literature survey with the goal of finding an anchor. A literature survey is an activity where you try to find prior and existing work for an area of interest to you. So for example, if your area of interest is statistical modeling of machine learning and video analysis in smart cities, then you would want a literature survey is the activity of finding papers in that area that have tackled that problem. And one thing that I would suggest to do is that you would go to a website like Google Scholar, which I showed the screenshot of here, and then put the area that you brainstormed in step one and add the keyword survey. A lot of time you will be surprised that you'll find a survey of papers already written for an area of interest to you. So for example, the area of interest that I've brainstormed in the last step, I found actually many surveys. These are two examples that showed up in the website. And what is nice about these survey papers is that it gives you a nice overall view of the field. So if there is, let's say, tens or hundreds of papers that are published about, let's say, machine learning and video analytics for smart cities, then instead of having to go and find all of those tens or hundreds of papers and taking a look at them, these surveys already done the work for you, and you can read them to get an insight about what is the current status of that research area. As an example, if I've opened one of those survey papers here. For example, here I found a survey on big multimedia data processing and management in smart cities. And if I go through that paper, I'll see that in a way they define the problem. So I also know how a researcher in that community would define the problem, would view the problem, and how to scope it. And then typically these survey papers are going to start talking and referencing existing papers in that area. So for example, maybe in the systems that are more related to healthcare systems, you can find that sub area, and that will help you also narrow down exactly what is it that you want. And I want to go here to the end, and you'll see that now we started with this general area, and if you go to the references section, you'll see that there is tens of papers that cover that area, right? So in this case, more than 100 papers that are referenced as part of the survey, and this can represent the scope of a research area that you can start getting into and learning about. And as part of learning about that area of research, what is a good activity to do is to try to find an anchor for your work. And the anchor is a principle that I like to use, which is if I want to start a new research project, it is good to have one or two papers that I think are closest to what I want to achieve, and then use these as an anchor to drive my own research. So for example, in the collection of all those papers in this survey, maybe I find that there is a certain area, let's say that multimedia ad hoc networks, maybe that's an area that I liked, and then I see the papers within it. And maybe there is one or two papers that I especially liked. I like the problem that they're trying to solve. I like their approach. So I'm going to use these papers as an anchor to say that I'm going to start or to have these papers as my starting point. Because in a way, when you think about research is really about taking existing work and advancing the state of science and the state of research. And you can take these anchor papers, a few of them, and then say that I want these to be the edge of science that I want to improve on. And in a way that could also be very helpful, as we're going to see in the next steps. Something else that I would like to mention, especially if you're beginning your research journey and it's very recent to you, also try these keywords in Google Scholar with the area that you're interested in. So maybe you look for high school journals, for workshops, and typically those are papers that are more accessible, that are papers that in a way can give you an idea, even if you are not or still not an expert or well versed with the research community that you want to work with. All right, so let's let's return to the slideshow mode, and I'm gonna also take another pause. Let's see the questions in chat. Okay, very good. So there is very nice questions here, which is how do I find the most suited journal conferences for publishing my paper, both locally and internationally? So, and in this case, for recommendation systems. Of course, I'm happy to answer this question in a way specifically in your case, but I would also give a general answer about, in a way, finding a suitable conference and journal. And also when you're even finding papers to read, what is a way or an indicator for you to know whether, in a way, what you're reading or the paper that you're reading are, let's say, of high quality or not. And of course, every research area is different. But there is a few hints that you can use to, in a way, get insights about this issue. So for example, if you find a paper, the number of citations can give you a hint of whether this paper has been influential or not. Another one, you can look into where it was published. So if it was published, let's say, in an ACM or an IEEE conference or journal, that also gives you a hint that this is, in a way, a peer-reviewed, respectable journal or conference that the paper is published in. So in a way, these are the types of hints that you can use to, in a way, have a gauge of the papers that you are finding. All right. Okay, so let's see. So there is a few other questions. So here is a very also good question, which is how to find research gaps. And in terms of research gaps, that's a very important problem that actually we're going to see in the next couple of steps. So I'm going to maybe hold off on answering that for now. Okay, very good. And then there is a question which is a very good segue, which is if we can give an example of an existing paper, which I'm going to do now in the next steps. Okay, very good questions. And there is, of course, some other questions that I'm going to hold on for now. But now, once we've, in a way, did the literature survey and and found an anchor for our paper or for our research problem, we are ready to embark on the next kind of like part of the step, which is in a way kind of like trying to read those papers. And in a way, the main challenge when we think about trying to find papers and find anchors is that this would entail reading a lot of papers. And as we've seen, there are tens, if not hundreds, of papers in a certain area of interest. So if we're going to read every one of those papers, that's going to take forever, right? So we're not going to be able to actually do the next steps. So the thing that we need to do is that when we read those papers, that we don't read them from, in a way, end to end, unless that we feel that these papers are absolutely relevant to my work. And there is a few papers out there that actually have a good overview of that process. So for example, there is a paper called How to Read a Paper, which is a very nice introduction into this process of reading papers in different phases. The first phase or the first pass is a pass that you can do in 5 to 10 minutes, which is just reading the title, the abstract, the introduction, the conclusion, looking at the headlines. And by only looking into these aspects, you can start getting an idea of whether this paper is of interest to you. And similarly, you would progressively, in a way, read more about the paper until you feel that you understood enough for the purpose of reading that paper. And then only for the papers that are going to be absolutely relevant to your research, those are the papers where you can actually spend days, if not weeks, really reading them and understanding them at a very deep level. But this does not have to be the case for all papers, but rather only for those few papers that you find. And now, once we have, in a way, identified these anchors, we get into the step 3, which is finding the research contribution. And let's take this example here. Let's say that after you've looked for work on machine learning and video analytics for IoT systems, that you found this paper. So this happens to be actually a paper that we published in our lab at UCI, which is about this topic of video processing in edge cloud systems and IoT. So let's take it as an example. Let's say that this is the paper that you're starting with. And now you want to find what is your research contribution based on that anchor. And this is also a process that I would recommend, is that you take a baseline, an anchor, which is a paper that you liked, and then you see how you can identify a research gap, a problem, a limit, and then improve upon it. In this case, what I would recommend is to follow these tasks. First, you would read the paper very, very carefully, that you would understand it at a very deep level. And of course, sometimes this might also entail reading some other papers to get some ideas that are referenced in that paper. And after you've done that, what I would want you to do is to answer these 4 questions. And those 4 questions are going to take you from understanding the paper to defining a contribution that you can start working on. So the first question is, what is the research problem that they solve? So in that anchor paper, what is really the research problem that they solve? And this may seem like a trivial question, but it's actually not a trivial question. It's not an easy question because you need to identify what sets that paper apart from other papers that were prior to that publication. Because in a research paper, in a research project, usually a lot of things are being done. But you need to have, in a way, kind of like the critical read that would allow you to find the special contribution of that paper. And typically, sometimes papers usually explicitly say how they view this research problem. So for example, imagine if we take this paper here, which is about multi-stage processing and transactions for video analytics in edge cloud systems. In this case here, even though that maybe they were using let's say, machine learning models, that doesn't mean that this is the research problem that they're solving. It could be a research problem that that is already solved from before, and they're building on it. So you need to find in a way what is unique about that paper in terms of the research problem that they solve. And it could be, in this case, for example, without getting into a lot of details, imagine that the problem that is solved in your anchor paper in this paper process is how to process at the edge node for fast detection. Imagine that their goal in this paper is that we have video analysis that is happening on the edge, and we want to do it kind of like on edge devices for fast detection. And then after that, you want to find the second question is what is the contribution compared to earlier papers based on solving that problem? So how are the authors of that anchor paper solving the problem in an innovative way? And an example of this could be here that in the paper that there is a unique two-stage edge-to-cloud process that balances between speed and accuracy. And then after that, you would start asking about the limitations of the work. Because you've read the paper very carefully and critically, you inevitably started thinking about things that are either missing in the work or things that you think might be done in a better way. So you think about what are the list of limitations of this paper. And for example, here, one limitation could be that the paper does not take advantage of neighboring frames being similar to each other. So maybe in the paper, every frame is treated independently, but then you also realize that, well, in video processing, that if you know what happens in the previous frame, it's very likely that is similar to the next frame. So maybe this is a limit that you might have identified. And finally, you would start thinking, well, what are potential improvements that you can do based on that limitation or the set of limitations that you have identified? So for example, you can say that, well, if I know that neighboring frames might be similar to each other, so maybe I'm going to cache and reuse detections for future frames. So for example, if I have a frame and I know that there is a frame, let's say from a few seconds ago that was similar, instead of reprocessing that frame, I can just take the detections or the outcome of that previous frame and apply it to my processing. Of course, all of these are examples, hopefully to give you the intuition of, in a way, kind of like how you can answer these questions in a way to find a research contribution that you can start working on. All right, okay, very good. So let's see let's take another quick pause. If you have any questions, please share them on chat. Okay, very good. So there is a question here, which is, could you give an example how an existing paper, or maybe for an existing paper, how to get a starting point? So that's a very good point. That's a very good question. And without maybe kind of like going into the like the deep details about the process, I think the previous slide with the paper of how to read a paper is a good way of, in a way, getting to know how to tackle reading a research paper. I think the main challenge, especially in starting a new area, is that there might be some work that the research paper assumes that the reader knows about. What is nice is that usually they would refer to it or reference that in the paper. So what I would recommend if you're starting to read a paper, like do the three-pass approach with the previous slide. And then as you're reading it more carefully, you can find the references that are going to help you understand the different aspects of the paper. Okay, very good. So I see here is that there's also some publication questions, which is also some of the things that I'm going to cover in the last step, which is the publication step. So we're going to get back to those questions later. All right, very good. Okay, so now, kind of like when we get into the contribution aspect, of course, a contribution can have different ways of thinking about what a contribution is. A research contribution could be a new algorithm. So for example, as part of the limits and contributions that we brainstormed for the previous paper, it could be that we're designing a new caching strategy that we can utilize for the problem. It could be a new model of the problem. It could be a mathematical model, a machine learning model that helps me understand and get insights about the problem. it could be a new way of looking at the problem. So maybe you change the problem slightly so that you can have better impact or maybe cover cases that were not covered in the original baseline or the anchor paper that you're basing on. Another typical research contribution is that maybe you have 2 or 3 anchors and you like all of them, and every one of them deals with the research problem in different ways. And what you can do is take all these approaches that you liked and then try to come up with a hybrid approach that would be, in a way, better than all of them by combining them all together. Of course, in some cases, this is possible. In some cases, it might be not straightforward to combine different solutions together. They might be conflicting with each other. But this is also a common research contribution where, in a way, you would put different work together. And finally, another research contribution, which is actually a very good way to both do a research contribution as well as learn and get into an area, a research area, is to write a survey paper of prior solutions. So kind of like if you find that there is maybe a certain topic where you couldn't find a survey paper, this is a topic of interest to others, then you could be the one who writes such a survey paper. And those papers are typically very valuable for other researchers, so it would also have a very good impact. So these are, of course, also examples of such of these contributions. It could be that you're designing a cache and reuse detection of frames, right? Considering the previous limits. Maybe you can come up with an optimization formulation of when and how to detect similar frames, right? So if I know that I want to reuse detections of previous frames, well, how can I measure similarity between them? That could be also another thing that you can do. And in terms of combining different approaches, well, maybe you can combine choices in the paper that you're using as an anchor, and maybe you use it with a clustering algorithm that you can use to find similar frames to be reused. So in fact, also hopefully that would give some intuition about how this can happen. Okay, very good. So here's a very interesting question, which is, what is probably the most impactful type of research contribution? Yes, thank you for sharing that question. I think it really depends, right? So for example, one could think of like each one of those types of contributions as equally important. When a new problem kind of like arises, a new way of looking at the problem, this would be important because really this is how you start tackling new problems and looking into different ways to solve them. But then after that stage, these two would become more important, right? Because the problem is already defined, so you need new algorithms. You would want to improve upon what is already there. And then these two kind of like would come later, which is once the problem reached maturity, you would want to have survey papers so that you can lead and guide future researchers about this problem. So I think the most impactful one of them depends on where is the research community in terms of kind of like the progress of that problem. But yeah, that's an excellent question. So let's see if we have another question here. Very good. So here is a question about, in a way, the kind of like the mental block that we can get when we, in a way, try to start getting into a research paper and start to work on the like find the right idea. So kind of the question here is how to find the right idea, how to get started, and whether the research idea is good enough to pursue or not. This is a very good question, and actually, this is really, in a way, what inspired me to start thinking about this process, which is a process that is, in a way, more predictable, that even if you get, let's say, to step 3 or step 4, and you feel that, well, maybe that's not really kind of like something that is fully convincing to me, you can, in a way, iterate, you know, if I can refine back to step 1. And of course, in every iteration, it's not like you're starting from scratch. You've already learned something. You've already brainstormed some ideas. So I hope that kind of like one of the things that I would like you all to do is that after this seminar, I want you to take these steps and try to apply them and see kind of like what you get with them. And hopefully it would help you similar to how it helped a lot of students that worked with us in our mentorship programs. Okay, very good. Okay, so there is a good question here, which is how does a hybrid solution how can it be beneficial for next researchers? So kind of like in a way, kind of like maybe I was referring more to the fifth contribution, which is a survey paper that would be beneficial for next researchers. A combination approach is useful because sometimes these combinations are not as straightforward as one might think. You have, in a way, different pieces, each one solve maybe a subset of a problem, but this fourth one, I would say that is one of the most value to practical approaches. So usually once a research area becomes more mature and ideas are out there, before they are implemented in industry, usually this fourth step is taken, and usually in more practical approaches, because usually in life, there is not one type of workload, not one type of problem that is being tackled, but rather you have, in a way, varying workloads, varying conditions, and for each one of those conditions, a different solution is better suited for that condition. So you will see in a lot of, in a way, kind of like industry solutions. So if you think about data science or computer science, data systems, computer systems usually adopt these hybrid solutions. And how to do these hybrid solutions right is an interesting question that sometimes is a challenging question that would require a research effort. All right, very good. And here is actually a very good observation also from one of you, which says that sometimes you can merge several types. For example, you can have a research paper that would make a hybrid solution along with a new way of looking at the problem. And this is absolutely right. So, of course, each research paper can be a combination of these different contributions. All right, wonderful. So very good question. So we're going to go on right now, and then we're going to take a pause in a little bit for other questions. In step 4, once you've identified what is your contribution and kind of like what is kind of like what you're going to be doing about your contribution, you're going to get into the 4th step, which is I need to validate my research contribution. Meaning that you want to be able to convince others that the research contribution that you're proposing is actually better. And to do this, you can do it also in different ways. One way that is very popular when we think about computer systems and data systems, which I know I think a lot of you here are interested in that area, that you would implement the new design that you propose, and then you would compare it with the baseline that you started with. So for example, in our previous example, in the previous scenario, if our anchor is doing edge processing, and maybe they achieve a certain latency or a certain throughput, if you implement both the baseline as well as your proposed solution, and then you can show that your solution is, let's say, 10% faster or 20% faster or something similar to that, then this is a very clear sign that you, in a way, pushed the boundary of science and that you improved an existing design. Other than that, other ways include simulation, that you can also simulate certain environments. In some cases, it is difficult to implement or run experiments, especially when we get to fields that are not as accessible, let's say, to implement as a computer system. So you can use a simulation framework to do that. And finally, you can also have a different type of validation, which is a deeper mathematical modeling of the baseline and the proposed design, and then showing how the analysis of these mathematical models are going to show you that that you achieve better performance or better accuracy, depending on the metrics that you care about. And now, once we've, in a way, defined the problem, worked on a contribution, and have a way to validate it, we get into the 5th step, which is the actual writing of the paper. And what is interesting about writing a paper, for those of you who didn't start doing so yet, is that technical writing is very, very different from other types of writing that you might be used to in school or in creative writing in general. And you'll see that kind of like one of the main differences is that in technical writing, you have a very clear objective and goal. You have a complicated idea, a complicated design, and you want to simplify it as much as possible. So the type of language you use, the type of writing structure that you use is also going to be as simple as possible because you don't want to add any complexity to the writing process or to the reading process. You want the complexity to be only in helping the reader understand the problem, understand the solution, and understand the contribution. One of the things that I always like to kind of like observe as well as in a way advice for students working with us is that in a lot of our writing we are used to have the punchline at the end, right? If you tell someone a story, if you write a novel or write in a way a creative writing piece, usually you are guiding the reader to the punchline at the end. What is interesting about technical writing is that a lot of times it's actually the other way around, where you give the punchline to the reader first. In a way, it could be your research conclusion, your design, and so on, but then you would explain it. So kind of like in a way, that's one of the kind of like interesting differences between those types of writings. And what I would recommend, of course, this in itself would, in a way, take a whole seminar or a series of seminars to really cover all the different details of how to have a good technical writing piece and what are the best practices for it. But one thing that I would recommend is to read papers carefully. Once you've identified in the literature survey of the papers that you're interested in, you can learn how to write a technical writing piece by seeing how others have done it. So read those critically and observe and try to mimic how they do things, especially looking at what worked for them and in a way avoiding things that you felt did not work out. Another thing is that there is a lot of resources out there about technical writing. So whether it's papers, blogs, books about technical writing, and a lot of them are kind of like very useful for someone who wants to take this seriously and want to learn about the technical writing process in a principled way. And finally, it's also good to find experts in the field who can critique and advise you. This is also very important, especially when you get into the actual writing of the paper and preparing it for publication. So having a peer group, maybe kind of like finding a mentor that is willing to help you in the paper, all of these are going to be helpful in helping you improve your technical writing. And finally, the last step here is, well, the publication process, which is after you've written the paper, it is a kind of like in a way a summary of all the work and the research contribution that you've done. You get into the publication process. And publication can really mean a huge range of things, right? It could mean that you just make your paper available, which is, of course, there is no, in a way, blocks that stands between you and taking your research report and putting it at a public repository that everyone can access. And depending on your goals, this might be sufficient. So for example, if you're just starting, if you want to use that technical writing piece to maybe show a future mentor or maybe in an application process to show them what you've done, this could be sufficient for that purpose. But also, in a lot of times, you would want to get a stamp of approval from a peer reviewing process. So you can also submit it to a peer-reviewed conference or journal that is going to be reviewed by researchers and experts in the area that you target, and then it would only be accepted if, in a way, they are convinced that it's a good piece of work. And of course, as mentioned in some of your questions before, different venues have different levels of competitiveness. Some of them are very, very competitive, requiring work that span years to be published. But some others are less competitive that are more accessible. And actually, some of these venues would target first-time researchers. So things like journals and competitions for high school researchers and undergrad students, those are very good venues for a first-time researcher to get familiar with the process, have something to show, get the stamp of approval from experts in the community, at the same time, while it is still accessible for someone starting to do research. And finally, one thing that I want to mention is, as Gafak mentioned in some of your questions, is that the research process can be isolating. There is a lot of knowledge that maybe is different from one research community to another. There is a process to it that has a lot of details that in a way require that there is a closer mentorship, a support system that could help you in achieving these goals. Of course, you can, in a way, still do a lot of this work independently, but finding a support system and mentorship is definitely going to be helpful in expediting that process and showing you the right way of how to navigate the different challenges that you may encounter. And kind of like for this, you can have you have different options, especially now with kind of like everyone being connected through the internet. It also becomes in a way more accessible to try to find such opportunities. But you can also reach out to your local researchers, like see in your local city or local county, kind of like what universities are there, what research labs are there, if they are willing to, in a way, help out or recruit a high school or undergrad student to work with some of those research projects. If you're already an undergraduate student at a university, typically there's a lot of faculty members, PhD students who are going to be happy to mentor an undergraduate student to work on research. But also there is some other avenues of doing so. So, for example, you can join programs that target helping young students to start their research journey. I know that a lot of you here are part of our community, and in fact, you know that we do programs as well as different kind of like boot camps and seminars that target helping students. So I think you've already have a check mark that you cover such programs and support system, and you can find a lot of examples out there that have such a support system. And actually mentioning this, we also always welcome kind of feedback of things that you would like to see that are going to be helpful in starting and continuing your research journey. And this would conclude the instruction part of the seminar. And thank you for all the wonderful questions that you've shared so far. Now we open it for kind of like an open discussion about kind of like various questions or comments that you may have. So please feel free to share them in chat, and I'm going to read them kind of like one by one and answer them to the best of my ability. All right, so let me open chat. Oh, very good. So here's a question actually about which AI tools can we use to analyze research papers, compare papers, and help us find research gaps. I think this is a wonderful, wonderful question. Unfortunately, I'm not too familiar with the way kind of like the most recent progress about kind of like these tools. I know that there is a few of them that are being developed. I expect that by the next few months that there's going to be a lot of development of these types of tools. And actually, maybe for anyone who is more familiar with these tools, I would love to hear about them, and maybe we can also share it with others in the mailing list. So I see that some of you have cited some of them. So yeah, I'm looking forward to seeing them myself as well. Okay, very good. I'm going to see what other questions there are. So here's a question, which is it possible to publish a survey paper as an independent researcher? How can someone increase their chances of getting published as an independent researcher, someone not associated with an institution or other accomplished researchers? So that's a very good question. And of course, kind of like there is a varied levels to answering this. Starting as an independent researcher, meaning that in a way, kind of like this is your first research project, of course, means that there's going to be challenges involved. There's a lot of independent learning that you have to do, a lot of challenges that you have to face, kind of like yourself. So it might be a lengthier process. But at the end of the day, there is nothing stopping, in a way, kind of like anyone from actually taking these steps. And I hope that today's seminar provided a roadmap of, in a way, how to approach this as an independent researcher. One thing that I would recommend as well is that for a lot of communities, if you look for papers or blogs about, well, how to write a survey paper, let's say in this area, you will find actually a lot of papers in this way that are going to help you find the process, and then also kind of like finding a good venue. Other than that, what I would recommend is that even if you're mostly doing your project independently, that you would try to find someone who could help you in, let's say, the critical steps of maybe the reviewing of the work, maybe giving you advice of the publication process or where to publish. And in a way, kind of like also programs out there, including our program, are can provide such help and in a way, let's say, kind of like these like few consultation type engagements. A very good question. So let's say there's here another question, which is, what are the skills we need to work on as undergraduate students so we can start our research work journey? That's a very good question as well. At least from our experiences working not only with undergraduate students, even with high school students. And my answer here is mostly based on data science projects, machine learning projects, um, um, even a basic understanding of, let's say, programming and maybe basics of how to use machine learning libraries, how to use data science libraries, how to do kind of like basic data management. So kind of like in a way, the basics of those. So for someone, let's say, who took a course on data management and machine learning and programming, this is definitely sufficient to start doing something as a research project. Of course, as you have more more opportunities to kind of like advance and learn more, you'll be able to do deeper research. But at the same time, you don't really have to have all that deep knowledge to start your journey. Think about it is that you're learning how to do research while you're learning how to do other things, right? You're still learning maybe deeper concepts about data science or machine learning, but you also started learning, well, what is the research process? These are two different things. As you advance in both, you're going to do great things. Okay, very good question. So let's see, there is a few other questions. So by the way, I think I'm going to apologize that I'm going to try to cover all questions at the best I can, but it looks like that there is a good number of them. So I'm going to try to cover as much as possible. Let's see here. Okay, that's I think where I stopped. Very good. So there's a question here, which is, can you please recommend some good mentorship programs that support beginners in research, like study groups or communities focused on writing research papers? I think that's actually a very good point. And actually, this is one of the things that we are starting to do now. So hopefully after the seminar, maybe kind of like within the next week, I'm going to release some information about having such a mentorship program where we can create a community of people wanting to do research together, and hopefully that can be helpful in that regard. And actually, since we are currently working on building such a research community and program, feel free to send to us feedback, like what are the things that you would like to see in such a community. That would be very helpful for us as we finalize the details of that program. Okay, so here's another question, which is, what are some common challenges that early career researchers can face when transitioning from coursework to conducting research in field of AI and ML if someone has technical skills? That's a very good question as well. And it's a very interesting kind of like aspect, which is even though like if you have some good technical abilities and you're an expert in some fields, once you transition to research, it becomes in a way a different type of task to tackle. You can think about research as a way of not only taking, in a way, or taking a problem and solving it, but really it's about kind of like trying to think, well, what is the boundary of science? And then how can I advance that boundary of science? And this is actually part of the process that I presented today. One of the ways of knowing whether what you're solving is an actual research problem is to see if there is a recent research paper that have tackled a similar problem. So hopefully by adapting the process that I presented today, that will help someone like you who have the technical ability to start doing a research problem. Okay, a very good question. All right, so let's see, here's a question. Oh, very good. So here's a question which is kind of like someone mentioning that they did some work on kind of like cancer using data sets, kind of like doing analysis with machine learning. The question is, can you tell me how I can show my work in a paper? And say that it will be the first experience. and if I can provide advice? That's a very good question. And I think of like this type of kind of like in a way, what you've done is that instead of the steps that we presented today, one could think that you started already on step, let's say 3 or 4. So you already did a contribution, you already have a technical aspect that you have. But then I would recommend you to go back to step 1, but you already know the problem area that you have, but then start doing a literature survey about that problem that you solve. Try to find an anchor, which is a paper that solved or maybe dealt with that data set that you are working with, and see if your approach is better than their approach. If it turns out that your approach is better than everyone else, then this is awesome. Then this is really a contribution you can publish. If it turns out that maybe it's not so clear, maybe you can think of how to advance your work so that you can show that it's better than what is out there, so that it can be publishable in a good journal. But yeah, very good question. Yeah, very good. So there's a question here, which is for research papers, does it have to be in computer science or can it be on other topics which are combined with CS? That's a good question as well. And as you kind of like in a way can explore, and I encourage you to explore in Google Scholar, similar to what I showed earlier, you'll see that CS and computing is almost part of a lot of other areas in research today. So starting from engineering to business to economics to arts, you'll see that computing actually now have a lot of different in a way kind of like influences and impact on a lot of different areas. So that's certainly a very good area that you would want to combine CS with another area or another research problem outside of CS. And also in terms of this exploration, I would encourage you to go to Google Scholar and in a way kind of like maybe write these 2 keywords. Maybe you're interested, let's say that you're interested in transportation systems. So write transportation systems, data science, and you will find a lot of papers that cover that intersection. And you'll find the same thing for other areas as well. So there is a very good question here, which is, what are the ethical dimensions of writing a paper using AI tools? And that's an excellent question. Of course, AI tools, in a way, kind of like started really kind of like getting, like we started seeing the huge potential of them in writing papers and research papers and really kind of like general writing as well in the last couple of years. And now we're starting that there is also specific tools that are used to actually, in a way, guide you in the writing process. To be honest, I think this is still a blurry area. I think talking from my perspective as kind of like as a faculty member, as a professor, both like when I think about course papers as well as research papers, there's still a lot of conflicting views about them. So I would say that for now, it's better to be more cautious. Maybe you use these tools as a brainstorming tool. Maybe you use it, let's say, for some more technical aspects of your research project, but you still try to kind of like do the actual writing, the actual implementation without relying on those tools. And of course, the main issue or the main problem that can arise with these tools is that you might be plagiarizing without knowing it. And that, of course, something that need to be addressed. So if you can use it in things where, in a way, there is no risk of plagiarism, I would say that this is typically would be fine. But if there is a risk of plagiarism, that's when you need to be extremely careful. All right, very good. So let's see. So I see that there is some other questions here. Okay, thank you all for those of you who are sharing kind of like your positive feedbacks. I'm happy that kind of like you've learned something and you're excited about what comes next. Okay, so there is a good question here, which is also, to what level point of time should we start working on research papers? Do we need to do it with others and collaborate, or can we individually produce papers? Working on a research paper, in a way, once you have a good idea, once you have basic technical abilities, and the ability to read a research paper and understand it, then you are ready to actually embark on a research project. And one thing that I actually would advise to do, sometimes when we think about a research paper, we get intimidated. We kind of like maybe think about those kind of like very competitive journals or conferences where like years and years of work has been done. Actually, just to be sure, so someone mentions that there is no voice. Can someone confirm if you can hear me? Okay, good. Okay, so it looks like that most of you can hear me, so maybe it's just one who can not. So hopefully, the voice returns to him soon. But back to the answer that I was mentioning, is that I also recommend you to like consider the kind of like journals that target young researchers, whether it's workshops, whether it's high school journals, whether it's competitions that in a way have a way for you to start your journey, and as you advance, as you would do more things. One way to think about this is that if you're starting your programming journey, to produce a website or to produce a program, you don't have to be at the level of, let's say, a 20, 30-year experience, let's say, software engineer at one of, let's say, the kind of like top software engineering companies. You can still produce something that would be useful for others, that would be something to show, even when you have one or two experience in programming. Same thing with research, that you work with the level that you have, and then start early so that once you are developing, once you are advancing, you can also advance your publication skills, as well as how to think in a creative way when we think about research. A very good question. Okay, so that's okay, good. So I see that stuff like there is some questions about in a way my contact details. I'm actually going to send an email as well through the mailing list for my with my email. Actually, I assume that all of you have in a way joined, and I've sent emails of confirmation to all of you. So in a way, you can contact me by replying to that email address that was used for sending the announcements. Okay, very good question. So here is a question about, in a way, kind of like someone, in a way, generally about someone pursuing a master's in data science. How can we secure, in a way, admission and scholarships to the US and getting to start in the field? And I think this is really one of the main motivators of me wanting to create, in a way, such a community, and in a way, trying to find ways to start this process of, in a way, having students start the process of research, because from what I see is that now we are increasingly getting more applications from students, high school students, undergrad students who already have research experiences. And what we observed is that those students with research experiences, these are the types of students that usually, in a way, people are interested in recruiting, in providing scholarship opportunities to. So hopefully by starting a research process and doing a research project, this is going to be very helpful in embarking and, in a way, kind of like finding good opportunities when you graduate. You're very good. Yeah, thank you. I see that some of you are also part of our data science for bioengineering program, where the instruction ended yesterday. For anyone who was not part of that program, kind of like we're going to announce future programs very soon as well. So we're happy to have you there as well. Okay, so let's see, there seems to be some other few questions. Okay, good. So I think for that, so there's some questions about that program. So feel free to contact me through the Slack channel for the Data Science for Bioengineering program, and I'll be happy to answer the questions related to that program there. Okay, very good. Wonderful. So for everyone who is mentioning in chat that they would like to be part of the upcoming programs, if you feel like you received our email of confirmation for attending this webinar, then you're already part of our mailing list, and we'll send you announcements for upcoming programs. If you're not, maybe you took the link from a friend or from a colleague, just feel free to send to me, and I'll be happy to add you to the mailing list. All right, wonderful, wonderful. Okay, so I think kind of like that seems to be most of the questions that we have. And thank you all for joining us today. It was a pleasure having you, and the questions that you all asked are wonderful. Really happy to have answered them and to have seen kind of like how you think about these concepts. Again, as I said before, we are starting to build a research project and community, expanding beyond the mailing list to something that is bigger than this. So if you have any feedback for us, please feel free to send us your wishes and suggestions, and we'll be sure to try to incorporate them. Wonderful. All right. Thank you all. And yeah, have a good day or good night.